Okay, so I'm just going to pull up our tool React. React is what we use for downtime monitoring. So here I'm navigated to a line. This is a SMT line, right? And this is the interface that a line operator would see. You can see it's flashing red, so I know that there's a downtime happening. The system is telling me something is going on. And already right away, this is the difference in our system. A lot of systems would require the operator to see that downtime is happening and then go in and manually report that it's going on. We monitor the line for downtimes automatically, so the operator is notified whenever it's happening, and they can come in here. And the next step, once you see that downtime is happening, with most downtime tools, the operator is asked to label it in some way. And that's a very manual process, as Andrew was talking about. So we have that tool as well. We allow operators always to manually label if that's something that they need to do to override the system. But the features we've been building and what we're excited about is AI features that automate this entire process. So you can see I have a live downtime that's happening, but there's also some past downtimes here. And I've intentionally left them unlabeled. But what the system does is if you look at the bottom here, it says insights. The system will give you suggestions on not only the label, so the category and reason for what a downtime might be, but also the machine that is to blame for that downtime. So we've set the system up. You can do a couple different ways. You can have it automatically label for you just with whatever suggestion our agent gives to you. That's more of a co-pilot mode. Or we have it set up so that the operator would review and apply. And then it's as simple as just applying the insight. And you can see that downtime now becomes labeled, right? So you go from having an insight, clicking in, and then just applying. Above here, I have another
So Joe,
downtime.
the system
Yeah,
behind the
please.
scene grabbed information from the voice of the machine, and I think you're going to tell us more like what that meant. But it had
Yep.
somehow already figured out exactly which machine was responsible, and then even it was the feeder, and then
Yep.
you just clicked apply without having to do that investigation.
Exactly. Just clicked apply. Similar here, I have an insight. This completely different. Before is telling me a machine error. Here, the system is telling me looks like there is a break, right? So the question then becomes, how does this all happen in the background? And just as Andrew was talking about, we take what we call the voice of the operator and the voice of the process. We combine these together into a synthesized document. This is a payload that we feed to the LLM to ask it to analyze and then return its best guess at a category and reason and machine. So we take the voice of the operator, context that the operator can gather in situ while they're examining and monitoring the line themselves. And they can do this simply by either typing into the system, or we have voice capture and voice transcription. So any language, anywhere, transcribed, used by the system to categorize, and voice of the process. So all of the machine data, all of the line data, everything that's happening across your line at any time is also used combined with that context from the operator to create this document. We then put that together and give it a prompt. I won't show you a full prompt. I will show you some pieces of a prompt, and we've redacted some things, and then I'll show you a bit of the payload, the synthesized document that we use. So a prompt would look something like this. This is obviously for an SMT line. So we would prompt LLM to say, act as an SMT line operator with deep knowledge of the manufacturing process. We'd say, you're about to be given a synthesized document. It contains a lot of relevant information. There's some things like the factory schedule, source data, so event timing, machine of blame. This is machine state data. This is an algorithm that we at Arch have developed, more of a data science algorithm. There's metrics of like UPH, takt times, things like that. And then there's operator comments left by the operator that was working on the line at the time of the downtime. We tell it what to pay special attention to. We structure in a way that the LM can make sense of that payload. We're not just dropping it in and then saying, hey, tell me what to do. And then we also ask it to give us a structured response, so a category and reason based off of the schema that we feed it. So this is part of the payload that we give. But what really looks like in the background is we're giving it this kind of called a blob of code that has everything from very specific downtime information about the what we call a job, or some people call a work order, where the line is, the shift information, what job is running on each machine, the takt times, the thresholds for downtimes, things like the factory schedule, as I mentioned. So exactly what shifts should be working, when a meal or break might take place. And this is something that we have features to store in our system. We can also ingest this from other system, like an ERP. Then we give it the schema or the setup for categories and reasons, right? Here we have, this is the results of a machine of blame algorithm that is run. So this, we're looking at the insights for that first downtime, which is here, these insights, here. And so, then we also put our prompt in here. And the result is we get a category and a reason. We get the alarm, we get the machine. And these are all things that we can then use to label and classify that downtime.
Hmm.
So
Yeah, so you
going
have to
back,
you
yeah,
talk to these AIs like a human kind of and a machine at the same time. So you showed how kind of like if anyone's used ChatGPT, you prompt it like you're an expert operator. This is the task I'm going to give you. And then but in real time, we are supplying these payloads of well-structured data about the machines and even the results of data science to then cause it to pick and return its response in a way that the software can automatically label. Is that good sound?
exactly. Yeah, exactly. And we're speaking to it directly via API. So all of it is done in code and then received in code and then pushed back into our interface. But it is, we're speaking to it like it was the operator. That's how it operates best, in a natural language. And then again here, we have the insights here. It decided it was a man category, reason break. Let's look at that payload. If we look at the factory schedule, we have the timings here for the meal. We have the timings for break, the different shifts. We look down at, let's see, there's no operator comments. There's no machine of blame. Adjacent machines were running upstream and downstream. So it took from the factory schedule and said, looks at the timing. I don't see a machine of blame. All the metrics look okay. All the machine states look okay. This was a break. I can tell by looking at your schedule that you had something already prepared. So gives it the category and reason right there.
Yeah. And do process of elimination too. Like sometimes there's just
Exactly.
an explicit machine error, but in this case, everything looks good, but the time and the schedule are off. It's got to be that one.
Exactly. And then you can just apply, your insight gets applied, and there you go. So you have the difference between an unplanned and a planned downtime, all being automatically categorized by the system.
Very nice.
Yeah. So those are instances where we have a lot of information, where we have, either schedule information can tell us, machine of blame, our algorithm can tell us and kind of start to shape and form what the LLM might say. But there's also instances where you might not have that, right? You might only have contextual information. So here I have a live downtime happening. What I can do, and what we encourage users to do, is, especially if they're using mobile devices like tablets on the line, or they have access to the interface on the line, is to add context that they can, even if it's a short blurb, whenever they can, add context for the system. So here I can come in, I'll add a quick comment, and we'll see what kind of insight we get back. Saw smoke coming from the oven. Very quick. I'll submit that. We'll give it a moment to transcribe here. Once the system transcribes, puts it into text format, adds it to that payload, which is then sent to the LLM, added into the prompt that we give it, and it responds back. So here, transcribe, saw smoke coming from the oven. I'll close. Let's look at our insight. And there, just from that, it can derive, looks like it's probably a reflow issue on the machine, somewhere on a machine, probably the oven, and you have a
Yeah,
label that you can
for
just come in and
those
apply.
for those familiar with SMT, that one maybe jumped out, and for those not, in the circuit board process, there is an oven which does solder reflow. And so you could have said that in any language, Spanish, Chinese, English. You just said smoke from an oven, and it was able to connect oven to the reason happened to be called reflow. It wasn't even the same word, oven, but it was able
Yep,
to reason that you said oven and smoke. Of all the reasons, that must be a reflow issue, right? So that was pretty cool too.
exactly. Yeah. Oven smoke. I'm an SMT operator. Must be.
So it can look through our detailed machine data and models, and it can learn from a sophisticated data science we've done. It can do process of elimination. It can see that there's no issues in the data, and therefore, oh, but there is something off with the schedule. And then it can also do reasoning of words in different languages to the reasons to understand, okay, it has to be this one because I know what you meant.
Yeah, exactly.
Very powerful.
Yeah.
Fantastic. Thank you, Joe.